Well, hello everyone. What we're going to do in this very short video is just demonstrate quickly how you would calculate the binomial probabilities in three different software applications: Excel, R, and Maxima. And this video is intended to accompany assignment 8, where you're going to be looking at how you update model weights or model credibilities using Bayes' theorem. And the easiest way to do this is through a computer. So this is just a quick tutorial on how to actually calculate binomial probabilities using any of these three different software applications. So a quick reminder of what we're trying to do here. We're trying to calculate the binomial probability as a function of some data. And the basic point here is that the binomial probability is a function of how many birds did you release, which is the basic premise for assignment 8, how many of them survived, and what do you believe is the underlying survival probability. And so essentially what you're calculating here is the probability of observing the data given this p-value here. All right, so k is the number surviving, n is the number of birds released, and p is the hypothesized survival probability. So here's a big ugly equation, and just wanted to step you through it. The left-hand side is, what's the binomial probability given some data? Well, what are the data? Well, how many survived, how many did you release, and what do you believe to be the underlying probability? Parameter p. This thing here that I'm indicating is what's known as the binomial coefficient. It's simply the number of different ways that you could have n individuals surviving out of k individuals surviving out of n released. And then if you kind of look over here, think about survival like a coin flip. You either live or you die, you survive or you don't survive. And so essentially what you see here, p is the probability of surviving, how many survived, k, 1 minus p is the probability that you don't survive, and how many did that? Well, it's the total number released minus the total number that survived. And if you just think through the algebra a little bit, you'll see that this superscript over here is the number of individuals that died out of the n total number of individuals that were initially released. So an example of the calculation here again is the binomial probability equation. Let's pretend for the moment that you released 12 birds and 4 of them died, and you believe that the probability of surviving is 0.65. So given the probability of surviving is 0.65, what's the probability of observing 4 survivors out of 12 individuals marked and released? So for on the left-hand side here, we write out the basic terms of the expression. So k is 4, n is 12, p is 0.65. This is the actual binomial coefficient. We're not going to worry about how that's calculated. We're going to let the computer do the work for us. But here's the underlying probability that we are hypothesizing, 0.65 raised to the 4th power. 0.65 is the survival probability raised to the power of, well, how many did you see survive? 1 minus 0.65, so that's the mortality probability. In other words, the probability of dying. How many did you see die? Well, if you released 12 and 4 survived, then 12 minus 4 equals 8, or the number that died. Put all those numbers in place, press the right button on the computer, and you get the probability. The probability, the likelihood of observing those data given that probability is 0.019898. Okay, so keep that number in mind, write it down if you need to, and all we're going to do now is see how do we actually generate this in each of the 3 different software applications, because as you're working through this assignment, that's exactly what you're going to do. Okay, so the 3 software applications will assume that you're choosing among are Excel, R, and Maxima. Let's start by looking at Excel. So I'm going to just jump out of PowerPoint here, and we're going to look at Excel. All right, I will go ahead and fire up Excel, and to calculate the binomial probability in Excel is relatively straightforward. See if I can make this a little bit bigger so that everybody at home can see this. We're simply going to click in one of the cells to make it active, and then we put in the equal sign, and then the actual function in Excel to calculate the binomial probability is binom for binom. And you'll see that you have a variety of things that are related to the binomial distribution. And in fact, it's the first one that we need, binom.dist. So you can either click it, or if you want, you can just type it in, binom.dist. And then we have what are called the arguments of the function. The arguments are how many individuals survived, how many did you release, what do you believe the probability is, and then there's one additional argument, which I'll mention in a second. So let's continue with our example where we had 4 survivors. We released 12. We believe the underlying probability, our model hypothesis probability, is 0.65. And then the final argument that we need to add here, and it's sort of indicated on the screen, we either have true or false. And this is important to add because we want the probability mass function and we don't want the cumulative distribution function. And for this particular course, it's not important to understand the distinction. Just understand that you need to type in the word false here. And if we do that, and if we actually can spell, which apparently I can't at this hour of the morning, then we click the enter key, and there we get our value, 0.019898, which we'll remember from the PowerPoint is exactly the right value. Okay, so that's how you do this in Excel. Okay, so next, let's see, how do we do this in R? And it's easy in R, it's easy in all of these applications, but I just want to show you how. Let me crank up the size of the font a little bit here so that everybody can see. And there we are. So in Excel, it's pretty straightforward. We simply use the command D binom for distribution or binomial, and we enter the arguments, which in this case are simply 4 survived out of the 12 that we released, and the underlying hypothesized probability is 0.65, and there it is, 0.0198977, just as we saw in Excel and just as we calculated analytically before. Okay, so that's Excel, and finally Maxima. Maxima is also very straightforward. You have one additional little thing that you need to do, but it's not particularly difficult. You need to load a little package which handles statistical distributions. Maxima is a math program, but it'll do a lot of the statistical things for you if you simply load the appropriate packages. The package that we need is called distrib, short for distributions. So it's simply load, and then in brackets, or in quotes rather, the word distrib, and followed by a semicolon. Okay, so there it is. And if you simply hit Shift Enter, then it will load this little package. You'll see a little command here that it's been loaded, and then we simply calculate what we need. We want a floating point. We want a decimal value for the return, so it's just simply float PDF binomial, and then the sort of what I call standard arguments. 4 survived out of 12 released, 0.65 is our underlying probability, double quote. So there it is, have a look at it. You hit Shift Enter, and there's our probability out to a lot of different decimal places. Okay, so that's it in Program Maxima. And again, you pick whichever piece of software that you want to use, and you simply use the software as a calculator. If you want to, and this is mentioned in the assignment itself, you can try generating an Excel spreadsheet or an R script or a Maxima worksheet to do all of the calculations for you in one place. That's entirely up to you. It's not necessary. You can simply do it one step at a time, or just simply use each of these pieces of software like a calculator to calculate the binomial probability given the 3 different hypotheses as talked about in the assignment. So hopefully this will help those of you who aren't overly comfortable or familiar with any of these 3 software applications. If you have any questions, please don't hesitate to send me some email. Take care.